Okay, now we're going to find the inverse of log and exponential expressions or equations. But remember, with finding inverses, like you do in algebra class, you swap the x and y's, you solve, and then you rewrite. Instead of y is equal, rewrite it as y to the raised -1 is equal. That was, for example, what I did. So we have y is equal to -3 log x, and I wish they did this, but putting that in parentheses is a good idea. So now we're swapping. The x goes on the left side, the y goes is part of the argument of the log. And now there's nothing else we can do. So that's when you use the inverse operation. So that's log base 10. So here's our b. So this is our b. Oh, wait. Before we do that, we have this attached -3. So we're going to divide both sides by -3, leaving -x/3. And then what we have is log base 10. Here's our b. This phrase is our n. This is our a. And we're going to rewrite it just like that. So our base is b. So our base is, our base is 10. This expression is the exponent, and the y is our a value. And then instead of y, we just rewrite it, and I put the y on the left side. Y to the raised -1 is equal to 10 to the raised -x divided by 3. Whoops. Or you may end up at some point seeing it like this. Remember, a negative exponent means it gets moved to the denominator. So, and this denominator of an exponent is the root. So it can be rewritten like this, but I think this is the answer that you'll see on the answer sheet. Okay. So we're going to rewrite x and y. We're going to swap x and y. We've got this extra 4 on both sides, so we're going to use the additive inverse and subtract both sides. Now, there's nothing else we can do, so now we're going to use the inverse. We're going to rewrite. Here's our base, here's our exponent, here's our value. So 2 to the x subtract 4 is equal to y, and then we're just going to rewrite y to the raised -1 is equal to 2 to the raised x minus 4. And that's it for this one.